A very good afternoon, one all gathered here. It gives immense pleasure to welcome everyone who gather here for the commemoration of Kavithundai Thiru K. Ramasamy Memorial Day International Webinar on Nanomaterials Synthesis, a roadmap towards industrial protection. For this webinar, Dr. AWAIS Ahmad, who consent to be a chief guest on this occasion, we happy to welcome you all and welcome sir for our program, and also all the academicians and head of the department, Dr. M. Neelakandan, Dr. S. Thalamuthu sir, and everyone who gather here, and Dr. M. Aravind, who coordinated this program, Dr. E. Ramachandran, and all the faculty members of our institution. On this great occasion, I welcome you all once again. With this, I close my welcome address, and now I invite Dr. E. Ramachandran sir to give the introduction about the chief guest.
Thank you, sir. Thank you very much for giving opportunity to introduce our resource person, Dr. AWAIS Ahmad. I am very happy to introduce about Dr. AWAIS Ahmad. He is an active researcher. He did his bachelor at college, University, Pakistan, and his master at MS at the University of Lahore. After that, he started his research career at University of Cardoba, Spain. After that, he working now as a senior researcher. He has published more than 75 research articles in highly reputed journal, and also more than 15 book chapter in elsewhere and other publishers. Currently, he's working in his research field is metal organic framework, nanomaterials, composite material, and heterogeneous catalysis, and electrochemical sensor formulations. The time is not enough to introduce briefly about Dr. AWAIS Ahmad. Now I hand over the session to Dr. AWAIS Ahmad to carry out the session. Thank you.
Thank you so much for your kind introductions related to me. I welcome you all of students who gather here to just listen about me or about my research career, about my research into this presentation, which I will present to you, is actually focusing related to the students. So I must say to the students that whenever you have a question, just put the question in the chat bar, or you can raise the hand, and I will answer as much as queries I can. Like, as we know that no one person don't know all the things, but as much as I know, I will answer it. So this is a session with the students, and with the interaction of the students, we will discuss with the research, with the recent trends of the nanomaterials, that where nanomaterials right now lies and where the recent development should be enhanced. So the topic of the presentation will be nanomaterials towards innovative and sustainable world for industrialization, for energy, for waste. Because we know that waste and energy crisis in our countries, like in India, Pakistan, Bangladesh, there are a lot, and I feel really honored to present my knowledge with my Asian country that just near to me as well. So the next point is this, that you belongs to a college which where you can polish yourself and where you can put your progress as much as you can, and in the other world you can perform better. So always remember that a university or a place didn't mainly recognize the profile of the student. The student have to make his or her own profile. There is a famous citation that dogs can bark only, but the lions can roar. So I must say to the students, so be the lion and don't be the dog. So let's start this presentation. So these are the research topics which we are dealing in our lab. It's heterogeneous catalysis, nanoscale chemistry, green chemistry, and flow chemistry. These are some of my distinguished awards. I have been a young scientist from Saudi Chemical Society, young scientist from Sweden, and I have been listed in top 2% scientists and in 80 scientific list as well. My Royal Soil Society membership. These are some of my distinguished positions as a visiting scientist in Paris, Chimie, France, Reggio Calabria, Italy, Di Salentino, Italy. These are my books which I have edited in Elsewhere, De Gutayer as well. These are some of my high impact factor papers. I must say that the impact factor and the scope of the paper can be achieved easily. If I can do, I was a backbencher. There will be some backbenchers today in this seminar as well. So I must say that it doesn't depends that a first seated student can perform well or a backbencher. It depend upon your work. It depend upon your time. So I was a backbencher student as well. So these are some of the papers, and there is the outline of this seminar. So we will discuss about nanotechnology, about the classification of the nanomaterials, about the families of nanomaterials, and which synthesis protocols nanomaterials can be achieved, and then their application in electrochemical sensor, energy, dye degradation, sustainable, and there will be some random as well. So let's start. What comes to mind when we think about the environmental catalysis? It's a very easy thing that if you think about environmental catalysis, the most emerging thing which comes to mind that these things can be tackled with the metal nanoparticles or the sporting nanoparticles. So what environmental catalysis can do, they can go for the degradation, they can go for the CO2 conversion, they can go for the biomass valorization, they can go for the hydrogen production. And how they can be synthesized? There are some methodologies such as mechanochemistry, microwave, microbial synthesis, or it can be depend upon the hydrothermal synthesis, co-precipitation. We will explain this in the next slides as well, that what are the environmental catalysis actually. So what is a nanoparticle? I know that you guys know about the watermelon. So don't throw a watermelon on the head of any person, maybe he will be died. So the watermelon size, it is 10 centimeter, is 10 centimeter. And what will and I think so there is the still trend of coins. I must say to the students that don't be silent, just also collapse with me and say yes if you want, say no if you don't want, say yes if you know, no if you don't know. So put your mics on unmute, and because it's a discussion talk, it's not a talk to just listen, it's a discussion talk. So put your mic on unmute as well so we can talk as well. So a watermelon size is a 10 centimeter, and a full stop which you can put on a paper, its size is 1 micrometer. And when we go about the nanomaterials, it relies into 10 raised power minus 9 meter, or it should be 10 raised power minus 8 as well, because there is no specific element for 10 raised power minus. So how can we imagine a nanomaterial size? What should be a size? Do you guys know actually what is the size of the nanomaterial? If anyone knows, hello?
Less than 100 nanometers.
எனக்கு ஒரு ஆள்
Oh,
phone
so
வந்துச்சு.
someone
நான்
speak.
எனக்கு எடுத்து
Thank
போட்டு
God. I was thinking that everyone is sleeping.
நான் தான் எனக்கு ஒரு ஆள் மெசேஜ்
So
பண்ணாரு.
here in this slide, we can
Is not open.
know about what will be the size of nano.
join பண்ணிட்டாரு.
If you guys think that a nanoparticle will be a size of a football, imagine it. If a nanoparticle is the size of a football, then a virus will be a size of a human body, a blood cell will be a size of a rugby field, and a kiwi bird will be size of a complete world. So now imagine that how much nanomaterials are porous in nature. When you and just imagine atoms are smaller than nanomaterials, and just check the nature, the rules of nature, that how these things are fixed in nature. We everyone speaks about that the nanomaterials have high surface area and low size. The actual thing is the size is the same, but the surface area will be increased in nanomaterial synthesis. What will be happen here is example. Is just check the first slide. Is a box who have 6 phases. One, if I can show by mouse, 1, 2, 3, 4, and 5 and so there are 6 phases of a box. And what will be the size of these 6 phases? It will be 54 inches per square. Now just cut this box into 8 blocks. So what will be the surface area after cutting into 8 blocks? It will be 108 inches per square. What was the reason? We just cut the slides and put out the block active sites. The problem was in bulk material that some active sites was blocked. So in nanomaterial synthesis, we actually activate the different sites where catalytical activity can perform. So we actually enhance the catalytical sites, and that's the reason the surface area of a nanomaterial increased. So what are the families of nanomaterials? Even you guys have family as well. I have a family as well, and nanomaterial have a family as well. Thank God it's not belonging to us, but it's have a family. So the first family is the metal-based nanomaterial. What in the metal-based nanomaterials? The metal will be interact with the metal. Like cerium will be interact with silver, copper will interact with cobalt, zinc will be interact with the silver. So metal into metal interaction is known as metal nanoparticles. And the second interaction is the carbon-based nanomaterials. What will happen in the carbon-based nanomaterials? In these, the material which will involve in the synthesis will be only carbon. You guys, who guys eat the pencil in their primary education? I know every student eat it. Who eat it? Again, you guys sleep. That's the point. That's the issue, that you are not listening properly. So you know or not? Okay. I will explain later. I will explain thoroughly. I will not ask anything right now. So the carbon-based nanomaterials are the materials which actually based with the carbon, such as graphene, such as buckyball. And what about the nanocomposites? These are the materials which can be interact with the different polymers, with the metal can be interact with the carbon can interact with the metal, a metal can be interact with the polymer, a polymer can be interact with the, any living resources. So there will be nanocomposites, the combine 2 or 3 materials. Let's talk about the shape of nanomaterial. So the first shape will be 0D. Why it's 0D? Because we can't decide the exact dimension, the exact root of this material, and it always will be in sphere form. As you know, like in the football and in the ball, you can't decide the direction, that from which direction it's formulated. So there will be a zero dimension. Then there is 1D, like tube. So tube have 1D, a single direction. Either it can be go from here to here, or it can be from here to here. So it will be a single direction. So it will be a fiber, it will be a tube. Then 2D, there is a like bed sheet, which can be flicked from upper side and from the lower side, just like a book, from upper side, from lower side. So it's a 2D material. Then there will be a 3D interconnected, just like the ropes, which are interconnected with each others, just like layers which moving inside of the each others. So it's interconnected, which can obtain every shape. Like if I can say, that is not a proper example, but you can get to know in this. Like water have no shape, but when you put water in the glass, it obtain a glass shape. So 3D materials are like that, they obtain their own shapes. Here is the example of 3D nanomaterial. This is the video of my lab to synthesize a styrene with a glycerol. So just watch the video. So here you can see that it's bind with the interconnected porous materials. And that's the theme of interconnected porous materials. So let's talk about nanomaterial synthesis. Mainly, there are three protocols. There are three synthesis mechanisms which works. Number one is chemical synthesis, number two is physical, and number three is biological. So let's talk about the chemical. So the chemical synthesis is actually in which material can be synthesized chemically, like hydrothermal, sol gel, macroemulsion, co-precipitation, chemical reduction. And the second one is the physical method. I will give the example like some students which are weak in the study. So sometime mom or dad goes angry and they slap, and then students start to work. So it's a physical method, so or a physical torture. So some nanomaterials don't want to be synthesized. So what we do the physical torture. We do the physical methods such as microwave irradiation, sputtering, thermochemical, sonochemical, irradiation, laser ablation. And the third method, which I must say that is very most convenient and good for wastewater treatment, is biological. What will be in biological? There will be any natural resources which will be combined to do the synthesis of nanomaterials, because biological elements have phenol oxides and metabolites which can be act as a stabilizing agents towards the synthesis of metal nanoparticles. So there are some application of nanomaterials. Number one is sensor, electrochemical sensor, then chemical reduction, then dye synthesis, solar cell, photocatalysis for wastewater treatment, supercapacitors, lithium-ion batteries, fuel cells, and bioimaging. Right now, you don't need to enter in your stomach. Just with some devices, you can see even the inside image of your stomach or your body as well, just with the help of bioimaging. And that only happen with the help of nanotechnology, because that devices are really, really porous and deals with the nanotechnology. So mainly with the methodology, what actually you students are going to do is, first of all, you have to synthesize your material, and you have to choose your precursor and your choice of method. And then you have to decide which catalytical activity you are going to perform. And there are some number of characterization techniques which actually tell you about the nanomaterials feasibility. Either it's formed or either it didn't form, which are SAM, TAM, XRD, EDS, FTIR, and UV. So, what mainly material right now is focusing. Here we present that magazines, which are interconnected materials, are actually dealing with the energy applications such as supercapacitor, such as sulfur batteries, metal air batteries, zinc iron batteries, sodium ion batteries, potassium ion batteries, and lithium ion batteries. So all can be dealt from which side? From nanomaterials. And here which material was modified? It was magazines. So let's come for the synthesis and their protocols. So first of all is hydrothermal. As from words, it comes to true that hydro mean water, therm mean heat. So what we will do a reaction with the water and with the heat, and then we will put our precursor. So here what we did, we put zinc nitrate hexahydrate with the C-tab and urea, and then we put a carbon cloth and did with the autoclave with the appropriate time and heating, and at the end we get zinc carbon cloth nanocubes. Hello, Kate. You are also joining the conference. Next method is also a hydrothermal. Here we just change a little bit. Here we involve sodium hydroxide and same zinc and with C-tab and with sodium hydroxide, and the method was the same autoclave, and we perform nanoflowers. Again, this was a very simple method. We take 0.1 molar copper, 0.03 molar cobalt, and there was a very simple method. And then we do for the electrode deposition on a carbon paper, and we get pine-like nanomaterials. Again, there is a hydrothermal synthesis with the zinc, cobalt, and urea. Why urea? Because it was a stabilizing agent. Again, we play and we get some sort of hexagonal shapes in our nanomaterial. That paper is published in Nano Energy. Then we combine zinc and cobalt, and again with the urea, and we fabricate it on a glassy carbon electrode, and at the end we get nano sponges. And here you can see how beautiful they are. So let's talk about the green mediated synthesis. So green mediated synthesis of metal nanoparticles, what you actually have to take, you can take any natural resource, any of natural resource. It should be a fruit, it should be a root, flower, honey, leaves, bacteria, algae, polymer, any. I just mentioned few of them here, but there are a lot. So just you have to think about that either they have phenol oxide or metabolites or not. Here, what we did, as you know, the GABA, we take GABA seeds, we make the powder, and we treat with the silver nitrate, and at the end we get silver nanowires, and that we use for the degradation of methylene blue. Same here, we take Texas sag plant and their extract, and then we deal for the degradation of methylene blue. And same here, we take zinc, silver, and we add the folic acid treatment, and then we use this for degradation of 4-nitrophenol to iminophenol and chromium 6 to chromium 3. And here you can see the shapes that we get nanoprisms or nanobars. And then we decided to go for the surface and subsurface modification, which actually deals with the recent trends of hydrogen production and the CO2 reforming. And that was a really interesting work which I actually performed in 2021. What we take a waste from our industry and we carbonize it, hydrothermally carbonize it in a carbonization cell, and then at the end we get biochar. And that biochar we use for the different applications in biofilter, in wastewater treatment, in energy application. And that paper we publish in JAWS. Again, electrochemical sensing. we will discuss is later. Let's discuss a very interesting research which actually measures on their face to glow their face. So what is inside in that things? They are benzyl alcohol, cyclopentanone, and these derivatives can be achieved from biomass conversion using heterogeneous catalysis. Just see here we get biomass conversions and we convert furfural alcohol into cyclopentanone. So this is the chemistry, and this is the beauty of the chemistry, that you as a scientist have to do the things which are the better of the life. So just think the phenomena which are really better for the life. And with this, we publish our review in Chemical Society Review, whose impact is 54.56. And here we present that how can we degrade or how can we get the pharma derivatives with the help of different biomass conversions. So the next issue is the energy crisis. What energy crisis do is right now, even in India, there is a load shedding, right? So the load shedding and the consumption of energy is really high. So what you guys have to do, you have to for the green hydrogen, blue hydrogen, and their synthesis, because it's right now trending. So how it can happen? You have the different hydrogen production cycles where you can get to know that how can you produce hydrogen from different methods such as autothermal, coal gasification, biomass gasification, natural gas reforming, supercritical water gasification of coal gasification as well. Photo fermentation process is very easy. Go for the photo fermentation. And that's the moral of the story, that the energy crisis can be controlled with the help of heterogeneous catalysis using hydrogen production, green, blue, and simple hydrogen. So that's the conclusion of the talk, that these nanomaterials can overcome the recent world issues. Number one is wastewater. Number two is pharma waste. Number three is energy crisis. So these three main issues right now trending in our country, in any Asian country. So this is my lab, and these are my international collaborators. And thank you so much, and acknowledgement. And it's time for the question. Hello.
Dear participants, kindly mute yourselves. If you have any queries, you can unmute and ask. Thank you, sir.
Please ask the questions. Please, as much as you can, ask the question.
Our bag.
I'm waiting for the questions. Hello.
Yes, Professor. Now the session is open for discussion.
Hi, sir.
Hello. Yeah.
Sir, I'm Bonaswaran
Okay.
from Tiruvagam North College. Our
Okay.
presentation is very nice.
Okay.
Sir, I will just started and synthesized some nanoparticles and nanomaterials.
Okay.
Sir, if you suggest any application studies, sir.
Okay. So
So
which
I-
application actually you want to do?
Sir, science oriented.
Okay. Biological application. And which biological application you are going to go for the biomedical, or you are going to do some antioxidant or antimicrobial?
Yes, sir. Antioxidant and antimicrobial. Some
Okay.
that kind of.
For this application, just make sure that your nano composite or your nanomaterial should be antimicrobial or antibacterial, such as silver, zinc, and you can combine with them. So just check the metals and their catalytical efficiencies. It's available on the internet. Okay, so
Okay, sir. Okay, sir.
if you have to take consent from me as well, so I even share my WhatsApp number. But I must say that go for the silver, zinc, or there is a very nice nano composite is nickel cobalt.
Yes, 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 yes.
Nickel cobalt are very efficient to do this antimicrobial activity because these are very effective to do these activities.
Okay, sir.
And
Okay,
if
sir.
you have more questions, I already share my number.
Okay, sir. Okay, sir. So thank you, sir.
Is clear? It's clear to
Yeah,
you?
yeah. Thank you, thank you.
You're welcome.
Thank you, sir.
Next question. Guys, please ask the question without fear. I am not a demon. So ask the question without any fear because I am here to answer your problems and discussion. With this discussion, your research will be good. Okay? Without discussion, a research entity can't be published. I have more than right now 100 plus papers, and it's only happened with the collaboration and discussion. A single person can't do all the things. It's all about discussions and collaboration. So ask.
Myself, Bhakti from Mumbai University. Sir,
Okay, is Bhakti Ji Thali? Yes. Your voice is actually so slow. Can you speak some loud? Hello. Hello.
Hello, sir. Am I audible now, sir?
Yeah, now it's very fine.
Yes, sir. Myself, Bhakti Thari. I'm doing PhD from Mumbai University, sir. And my
Oh,
topic is nanocomposites for the.
stabilizing agents. Is that true? Is that true?
Yes, sir. Actually, sir, during the electrochemical properties, we have used Nafion, PVDF. We have tried
It's
with
not of
various.
stabilizing agents. Dr. Thali, help of some stabilizing agents. What happening with you? You are synthesizing your material, but the size is not controllable. So that's the reason they are non-controllable and their size is very large. And that's the reason their catalytical activities are blocked. And due to this, your efficiency on your energy application is low. And even they are not responding to current. Am I right?
Yes, sir. Yes, sir.
So put CTAP and urea and NH4F. NH4F is very good. And if you have more questions, I already shared my number and you can discuss with me anytime.
Sir, and one more question I have.
Yeah.
For the electrochemical sensing part, like how to select the drug molecule or any analyte for determination, sir. So, sir, could you
Yeah.
throw a light on that as well?
That's a very generous question. And for this, look, like there are a lot of dyes, lot of pharma waste, lot of heavy metals such as chromium, nickel, arsenic, ibuprofen, paracetamol, which actually in Asian countries there are a lot. Okay, so what the main point of your sensing? Do you know that there are three type of catalyst in nature? One is acidic, one is basic, third is neutral. Do you listening
sir.
me? Are
Yes,
you
sir.
listening?
Yes, sir. Yes, sir. Yes, sir.
A acidic catalyst will only work with basic elements such as base dyes, such as ibuprofen, such as paracetamol. This is the nature of acidic catalyst. But basic catalyst, what a basic catalyst will do, it will remove your heavy metals because heavy metals have a catalytic behavior. They have positive charge. So they have acidic. As we know the theorem of Lewis acid and base.
Yes, sir.
So don't make the wrong chemistry. That's the reason we are not getting results. What students do, they synthesize the acidic catalyst and they are removing acidic elements from the water. It never will be happen because acid to acid always repulsion. As in physics, positive to positive is repulsion. and you have to be connect a cation to anion to remove element or to degrade element. So acidic catalyst for base things, basic catalyst for acidic things. And there are some plenty of things which I will share. I will share to you as well.
Yes, sir.
Okay.
Thank you, sir.
There is one question from Ramachandra, that how to avoid resin type nanoparticles during green synthesis. Okay, so green synthesis actually happening by with the solvents. So what you have to do is to how to avoid resin type nano. What happening in the green synthesis? Sometimes cluster involved during the green synthesis, because what students do, they emulsify their green synthesis by putting a lot of extract rather than a solvents. Always try to wash your any extract 4 to 5 times using centrifuge. Don't do with the filter paper. Filter paper have a cellulose and phenolics, and that's the reason we get reasons and we say, oh, it's nothing happening. So avoid this. No cellulose, centrifuge. Next question.
H2O வெளியே போய் இது வந்து பைண்ட் ஆகும். ஓகேவா? இப்போ
Guys, next question.
ஏதாச்சும் சாஃப்ட்வேர் யூஸ் பண்ணி ஸ்டடிஸ் பண்ற மாதிரினா என்ன மாதிரி பண்ணுவோம்? ஏதாச்சும்
Hello.
BFT இங்க பண்றோம். ஓகே. அதுக்கு ஒரு மொழி அதுல தானே
So, one audience asked question in chat box.
I think இங்க பண்ணுவோம்.
Okay. Okay.
நீங்க பண்ற ரிசர்ச்.
Okay, the next question, sir, will there be any change to the nanostructure if it was dried at high temperature such as more than 100 degrees centigrade? Okay. Every metal have a stabilizing point, have a thermal stability. But there is a point. When a metal nanoparticle synthesizes, then it's to oxides. So oxides have a potential to bear more than 100 degrees centigrade. Even you can calcine it. You always calcine. Even during calcine, the nanostructure can't be altered. Only what you did, you don't use the gloves because you hate the gloves. But what the reason to use the gloves is is not to involve the impurities, because you always what can I say, your own self impurity in your nanomaterial, and that actually disturb your nanostructure. So always use the gloves during nanomaterials, and it's not a problem to dry it at 100. The next question is from the Padma Bahan. Focus of nanomaterials in dry biology. And you can mute yourself. There is a lot of noise. Okay, dry biology. Okay, my 2 students right now working on anti-cancer activities, cell lines. What we did, we synthesized quantum dots, and we are dealing with the cell lines, cancer cell lines, MCF7 and MCF6. Right now, we are working on it, and some good results, I hope so. Next question. I think so that there is a question from the audience.
Yes, sir.
Yeah.
Sir, one more thing.
Yeah.
So yes, actually, I have tried also nano composites of polyaniline and metal oxide, sir. So that is through oxidative polymerization reaction. So in the end, we get emeraldine salt, and then we can fuse it with the metal nitrate and the metal oxide and polyaniline composite. So,
but you can use what you can use. You can use core shell of a polymer. Okay, have you listen about pellet nanomaterials?
No, sir.
Okay, what zero valent nanomaterials do that? For example, if I put you in a room and I lock the room and I go somewhere else, then your excitation will be only control in a room, right?
Yes, sir. Yes, sir.
But outside, there will be no noise, there will be no excitation. So these nanomaterials, zero valence nanomaterials, behave like this.
Chat box
So here you can do a stabilizing phenomena with a polymer such as chitin, such as alginate.
போட்டிருந்தா ஒரு பொண்ணுக்கு போட்டிருந்தேன் அது சொல்லிட்டாரா
Okay, sir.
And that's
Sir,
very
actually, yes, sir.
very, very effective for your supercapacitor. I already tried and we get very excellent. That paper we published in Materials Today, whose impact is 31, and it was a single trial reaction.
Okay,
You
sir.
can imagine that how much
Sir, so actually, the autoclave and other things are not. So we are trying only co-precipitation, sol gel, and the basic techniques with much instrumentation. So is that a problem, sir?
which university you
And sir, can we use?
in which university?
Sir, Mumbai University. Sir, Mumbai.
ಇಲ್ಲ ಈಗ ಒಂದಿಸ್ ಬರೋಣ. என்ன சவுண்ட் வாய்ஸ் ஏன் எனக்கு வர மாட்டேங்குது சத்தம்?
And soldier, you have to use sodium hydroxide.
Yes, sir. Yes, base. Yes, sir. So
Yeah.
that's what I wanted to ask.
Yeah. So you can't use CTAB. So we will discuss.
Okay,
I have
sir.
some links in IIT and Mumbai as well. So don't worry. The instrumentation and characterization is not a problem. Problem is you have to work.
Yes,
If
sir.
you are
Yes, sir.
good in work, if you have good enough in work, because everyone demands results, Ali. Like if
Yes, sir.
you come after 2 months and say I did nothing, then what should I do? I will say, okay, I have to not to go for more collaboration. So
Yes,
you
sir.
have to work and you have to give the results. You have to prove yourself. The instrumentation and the characterization is on my side. I will take the responsibility.
அந்த ஸ்ட்ரக்சர் பிரிக்க முடியாது ஆனா அதுல பண்ணலாம்.
Thank
Okay.
you, sir. Thank you so much, sir. Yes, sir.
You're welcome. You're welcome.
Jay,
So the
we-
next
we-
question
we-
is that,
Ama.
hi sir, I did hydrothermal
நான் பார்த்து சொல்றேன் சார்.
synthesis to synthesize metal oxide. Okay, but what is the question? I use CTAB as a surfactant, but getting more agglomeration. How to avoid the agglomeration? Okay, don't use the CTAB, use NH4F rather than CTAB. Sometimes CTAB give more agglomeration. So use thiourea or use NH4F. The next question is, sir, could you please suggest any efficient dopant material used to synthesize zinc nanoparticles, zinc oxide actually? Okay, there is a two option. Try with the cobalt and nickel, and they're 1, 3, and 5% doping. Don't go more than 5% dopant, because more than 5% will result to actually the drawback of the study. So more than 5% doping is actually showing that you are putting more dopant rather than your material. So 1, 3, 5. These are very specific ratios for your dopant. And the next question is, in what ratio I want to take surfactant with the metal? Okay, that's actually a good question, but it's depend upon your study, like or it's depend upon your metal. For example, cerium, I use ytterbium, I indium, so the palladium, ruthenium. So these materials already have a high oxidation and they are already are bulk in nature. So what happen in these ratios? In this one, I will not add a lot of ratio of surfactant. I will add very less surfactants. But when I deal with the nickel, silver, manganese, these will be like this. These will be for, I have to increase the ratio. So the next question is from Vandana Shinde at YouTube. Green synthesis of nanostructure commercially possible? Yes, possible. If you can go for the bulk, I saffron pharmaceutical, and we synthesize in bulk. Okay, it's a time taking, but just think with the mind. If you can save the money, and you can invest a little time. It's a more so green synthesis of okay, you can increase the agglomeration as well. Even in the green synthesis, you can involve CTAP, you can involve sodium hydroxide, and it will increase the your product, but it will be not complete green synthesis. Remember that. For the complete green synthesis, have with the sodium borohydride. Any more questions? More questions, guys? I think that
Dr. Request Dr. Anuraj to say what of thanks.
okay, thank you so much. I must say,
Good afternoon to all.
I must say to the students that students in the institute in which you are right now working is a national engineering college. Okay, so sometimes you guys, we have limited resources, the organization is very less, blah blah blah. Students have a lot of problems, but I can tell you one thing: the last fire burns more always. So when you will know how to work in the limited resources, don't make the lame excuse. Don't say this that you don't have to do work in such environment, you have nothing. Trust me, you already have a lot of things. Okay, in which environment I work, I can't even explain. So resources, in limited resources, when students work, so if a person survive in limited resources, he or she will be a great scientist. I will not say a scientist who stay in a great lab and work in a great lab and prove himself a good scientist. A scientist will be a scientist who know to publish a paper in limited resources, how to recognize yourself in a limited resources. When you go abroad, when you study abroad, and says my country, remember that when you forget homeland, you will forget and all the things. You will be misled. You will go in the wrong phase. Don't forget your teachers. Don't forget your parents. Wrong things with the friends are investing on you, and respect your teachers as well. And that's the moral. And from my side, that's roar like the king. Don't bark like a dog. That's it. Thank you so much.
So thank you so much for your Naraj. I am here to propose the vote of thanks for this webinar. So to that speaker of this today's webinar, Mr.
Thank you so much, sir. Thank you.
AWAIS Ahmad, senior researcher, University of Cardoba, Spain.
Yes, sir. Thank you.
சார் பேசுறாரா?
Hello.
கேட்கலையே, வாய்ஸ் கட் ஆயிடுச்சுங்க.
So I think so that there is a problem in the internet connectivity. I think so.
1 minute, sir. He will join. 1 minute.
Okay, okay.
Sorry, there was some internet issue. So first of all, I express my sincere thanks to today's speaker, AWAIS Ahmad, for accepting our invitation to give the webinar on the August occasion of founder chairman memorial lecture on the topic of nanomaterial synthesis, a roadmap towards industrial production. Your lecture was it was wonderful, and it was timely needed for the researcher who are in the space of synthesis of nanomaterial. It was highly basic and very informative for the researcher who are in the phase of synthesis.
Thank you so much for your coming and your interesting lecture. Thank you so much, sir.
Thank you, thank you. It's really honor to present myself in the front of you guys. You determined one, you hardworking ones who are actually making the students on the high level, because a teacher is a person who stay always on the same place, but the students always go for the high success. So that's really really great. Thank you so much. Thank you so much for this honor.
I extend my sincere thanks to the management, director, and principal of this institution for allowing us to conduct this webinar on the August occasion. Also, express my sincere thanks to the head of the department of our department, Science and Humanities, Dr. M.A. Nilagandan, for their constant encouragement to conduct a webinar like this. Also, I extend my sincere thanks to all the audience. So whatever may be the program, audience is important. So we frequently conducting the webinar, so we are getting overwhelming responses from the audience. So that inspire us to conduct the more webinars on recent advances in the recent research topics. So based, so I thank the audience who are supporting us all the webinars. Also, I thank all our colleagues, faculty members, and students for joining with us. Thank you so much. Thank you, one and all. Thanks for the opportunity given. Thank you, one and all. Thank you so much.
Thank you so much, sir. And that's it. Should I close right now? That's it.
Yes, sir.
Okay.
You can close the session. Also, I request the audience to leave the meet. The participation certificate will be delivered with a couple of days through your registered mail ID. Thank you so much. Thank you.
Bye bye, Arvind. Bye bye, everyone. Thank you so much. Bye bye.
Fine, sir. Sir. Camera brother, thanks to you. Better.
Thank you, sir.